Um, I guess for my personal view, I am more concerned about going after the most like quantum healing type of things, the things that are very clearly not correct. So because you can fight forever about like what's the nature of wave function, that can get tricky very easily. That can, like, we can spiral just and go forever on this. I myself on the side of trying to be more rigorous and lose a few people, but also creating trust. But at the same time, if I have to choose and prioritize, I will just pick the things that are clearly not quantum and say, this is not quantum, please stop. Because just for a matter of, because I come from a point of view of being concerned of the quantum mysticism and this real bad societal implications, so that's my priority, but that's very personal for me.
Well, it is a good sign. People believe the quantum is a good meaning and related with the health and yeah. Okay. Next.
Oh, okay. So I talked about. In fact, my talk is about that balance between being precise and being more accessible to the public. So actually, I had several experiences that I gave a public talk to elementary school students actually. Mm-hmm. So my actually it was surprising to learn that actually you don't have to talk down any complicated concept to the elementary school student. Actually, you can just say it as is. Of course, you don't want to make it more complicated than necessary, right? So you don't want to do that, right? But you don't have to make it like animated, mm-hmm. right? You can say it as is. And I think that is a fine line. You can do it.
Okay, thank you. Okay, let's continue. Okay, first speaker.
Yeah, so I think you can have a bit of a layered approach, right? So I think that there are people who don't necessarily want a lot of detailed information about the science and the technicalities behind quantum mechanics itself, but they may want to understand how quantum technology could affect them personally in positive ways. And so I think what we need more of is diverse communication across the board. So different ways of which we can teach the quantum mechanics, because there are plenty of people that are interested in that, but we also need different ways to disseminate what are the benefits of quantum technology and how will it affect society on a broader level. And so I think that it's not so much about simplification versus balancing technical explanation, but how do we reach people in different ways, because everyone is going to interact with this technology different and has a different buy-in for it.
Mm-hmm. Okay. In the first session, we also talk about the gamification of the quantum concept, and then the interesting game can convey the right and the proper concept, but sometimes we can make, unfortunately, the misconception or the mysticism probably. When I look at the quantum toothpaste, I want to buy. So, okay. Probably I have a good thought about the quantum. Okay, let's move to another question. Probably this question also will be shared with the speakers in the first session. What makes the quantum science particularly difficult to communicate compared to the other technologies such as the AI or the robotics? So how do you think? Okay, you first, Sarah?
Yeah, so I think the biggest difficulty with quantum is that it's very difficult for us to interact with it on an everyday level. Mm-hmm. So I think with robotics, it's very easy to be rawed by robotics because there are human-looking robotics. There's the Star Wars-looking robotic that Jensen Huang had on the stage with him. And this is it's really exciting. People get to see technology up close and personal, and they get to interact with it. And so quantum's a bit more difficult in that aspect because you can't necessarily see quantum effects every day. And the quantum computers, I love when they have them at conferences because people get to gather around them and be just like, they're shiny and they're pretty and the chandeliers and everything. But at some point you're also standing there thinking, okay, but what does it do exactly? And so I think that's what makes quantum technology a bit difficult to to experience in terms of other technologies, because we can't see the quantum effects, and when we do see the technology up and personal, we're not really sure how it relates to our everyday lives. So it's difficult to relate to the technology.
I see. Okay.
Yeah, I totally agree with what has been said. So quantum mechanics is not something that we interact with everyday life, right? So, and also, as I said in my talk, that quantum mechanics is fundamentally abstract. Yeah. So what the world exists in the abstract form, right? So you have to accept that. So it's very difficult to explain what that is actually, right? But at the same time, of course, that's challenging of making quantum mechanics to more accessible to the public. But also, I think it's kind of, to me actually, personally, at least, is opportunity, because quantum mechanics or quantum science is not just technology. It's in some sense philosophy, that the way you look at the world. So I think there are a group of people who are much more interested in this aspect of quantum mechanics, not just technology. So quantum mechanics is a combination of technology and philosophy and everything. That's what I believe.
Yeah, like relativity.
Yeah.
Okay. Next.
Well, for sure, the main problem is exactly what both of you said. It's hard, it's intangible, it's hard to just make experiments different, like from, I don't know, explain moment of inertia with a little thing that like spins is much easier, right? And I think, going back to a point of my talk, I feel like a bit of the physicists are to blame, because they just are too comfortable with falling for the idea that it is too difficult, so it's not worth explaining, and kind of feed their egos with that. And also the fact that we don't fight enough whenever there's a problem in communication, which snowballs and makes it difficult to communicate. So I think those two things are so difficult together. They're really a problem.
Okay.
He has a fantastic answer to this question.
Okay. Please hand the mic. Turn on and then try.
Now? Now? How about now?
Yeah.
Oh, okay, perfect. Yeah, thanks. Thanks for giving me. So the example I use is, when we are talking about this, like when you're a physicist and you want to explain quantum mechanics and quantum technologies, you generally use the notations and the mathematical language, and you assume that it's you have to use mathematical language, but it is very similar to like trying to discuss on German literature without someone knowing German. And the reason we have 4 semesters of like calculus and differential equations in semester before we go into like quantum physics is that you learn a new language and then you use that language because it's very efficient. But you can't do this for outreach or science communication. Like you can't expect people to have 4 semesters of like quantum, like the notation and the mathematics of it so that they can start discussing. So it is on us to find different ways to explain this stuff. I mean, for other stuff like robotics, AI, there are ways. For example, nobody in AI starts from like statistical inference and like going over what are the like transformers and stuff. But for quantum, for some reason, we start with like bits and qubits and like, bracket notations and all that stuff. So we should definitely stop doing that.
You see. Okay, probably the speakers in the first session will also have some comment and yeah, please.
I think both AI and quantum mechanics based on the linear algebra, so it's the same abstract in some sense. But I think AI can be more popular to the audience. That is because they are very concrete outcomes, such as large language models. So everyone can can use it and experience it every day. So maybe we can think of how the quantum things can be produce such kinds of things, and then everyone can experience every day, so they can understand themselves, even though they still don't know the real mechanism, but they can be more familiar with these kinds of things. I think that is what I expect we can, if we would like to promote or outreach for the quantum technology, that is what we can do.
Yeah. Probably we also need some practical experience for the quantum technology. Okay, then over there.
Thank you. I'm Doug Robinson.
Can you turn on the mic?
No, it's working. Like this, maybe. Is it working? Now it's working. There we go. So I'm Doug Robinson. I'll be chair of panel 4 this afternoon. And I'd just like to kind of follow on from Zeki about the language thing. I mean, all of this mathematical language represents things. It describes things, and we manipulate it for our own good. This is why we train as physicists to do that. But I like this idea of representation. I missed the first panel, so I guess there was some discussions about representation through art of different things. And so when you decipher the mathematical language and put it back to its basics, what it represents, then you have the beginnings of a conversation that you can convert into other types of language. And I think, for me, that's where it starts, right? I don't think people are stupid. I think it's about, as you said, about the language. But language is about representation of things. And so this is where we have this, let's say, Let's say general purpose engagement tool, which is what is being represented, the descriptions, and the phenomena. And sorry, I'm just throwing that in as an extension of Zeki because I really believe in that. And then when you do that, you can think about art, to have a conversation through that language and other languages. But I think you have to do that deciphering step. As a former lazy physicist and another former lazy physicist, I really believe in that.
Okay, thank you. Any comment? No? Okay.
Actually, sometimes I really think hard about the language differences between physicists and public and so on, and I also thought about how to explain this to the difficulty between these two words. So one example I thought about is like Van Gogh's Starry Night. I like paintings, right? So suppose that you are trying to explain Van Gogh's Starry Night to blind person. How can you do that? So to me, in some sense, maybe I'm wrong, but trying to explain quantum mechanics in its purest form to public is like explaining Starry Night to blind person. So there is a kind of fundamental difficulties and so on. So maybe yeah.
Okay, any other question? Any other comment? Opinion?
Just something to add on to the last comment. The analogy between explaining to a blind person how a painting looks like, although they cannot draw that painting to one, I believe still the blind person could imagine based on your explanations of the paintings, what emotions the paintings bring, and all sorts of experiences you have. So although I think it will be very hard, and while explaining, we can lose the original meanings of quantum physics, the original definitions and all the intricacies of quantum physics. But to me, it's kind of there's too less exposure to quantum physics for the masses. So, for example, in Korea, we first learned quantum physics when we were in undergrad school. We actually never had, I mean, some people do, but we usually never have a chance to study quantum physics in any form. And And although I do understand that we need mathematical language to understand them in full capacity, I also feel like early exposure could rule in many teenagers or more younger people to have interest in these kind of topics, and those could go a long way regarding this. So.
Yeah, I agree. I'm saying that I'm not saying it's impossible. Of course, you are trying your best to explain this thing to blind person and so on and so forth. Blind person can have some kind of image, and maybe very good image at the end of the day. So I hope that that's possible, but I don't know how much you can push this far. So that I don't know yet.
Mm-hmm. Yeah, probably this comment will be continued to the misunderstanding and mysticism and then pseudoscience things. So do you have any idea about how we can the attack or the provide the proper and good the concept about the quantum physics?
I agree a lot with you, and I think I'm gonna make a controversial comment here, but I think something like Ant-Man or whatever representation that is not super correct is still better than like a scientist that is not careful and says that aliens have quantum computers, right? Because people believe scientists, sort of, now I know that they don't so much, but they sort of still believe scientists. So meanwhile, when they're watching fiction, they have a little bit of a clarity that, well, I cannot learn quantum mechanics or robotics or whatever from this Netflix show, you know? So, and I also, for a personal anecdote, I come from a place not super poor, but poor enough that people were not like aiming to go to a good university. They always like no one consider being like a lawyer or anything, and I never considered to be like the possibility of being a scientist until I ran into like a magazine, and there was an article about the scientist was Lisa Randall, and I was like physicist, like a women physicist. Because the last one that I saw was like Marie Curie, you know. Not that I didn't know, it's just that it was so far away from my world that it never occurred to me to become a scientist until I just look at it. So I think even if you just putting scientists and science just within reach, even if it's not perfect, and I think a lot of science communicators and scientists are struggling so much to do something perfect, that they fail to recognize the social impact to have science close to the public and how life-changing can be. And I know how life-changing can be for my personal experience and also from my efforts and hear from other people saying, wow, you inspired me to pursue science. It's like, I'm just doing my thing. And it's fantastic. It can be life-changing.
Okay. Sarah, any short comment?
Yeah, so I think that education is a big part of this, and so I love that you said that we should still expose people to the basics of the quantum mechanics that underlies quantum technology, and I think that the exposure is important. So they've done studies to show that if you teach quantum mechanics at younger ages, I think the specific study I'm thinking of was 13 to 14 years old, that after a semester of doing so, they performed better on an exam related to quantum mechanics than university students. And so I think that oftentimes we underestimate the ability of children and young students to actually comprehend really complex topics. And in fact, it's actually really ideal to introduce complex topics at younger ages. And so I think that we should really focus on education because, as I mentioned in my talk, in the US especially, physics is not required at the high school level, and it's not even required at the university level. It's reserved for those who go into engineering and the physical sciences. And also to build on the personal anecdote, I did not have physics in high school, and I didn't have it until university. And the first time I took it, I actually failed. It was the first class I had ever failed, and I thought it was the worst subject on the face of the planet because I did not understand that physics is really about critical thinking. It's about thinking through a problem. You can't just memorize formulas. And so it took me about a year to get back to it. And the reason that I went back to it was because I had read the memoirs of Richard Feynman. I forget the name of it. It's a question. I forget the name of it. But it didn't really talk about science as much, but it was just his adventures. And I thought, for some reason, it really, really fascinated me. And so I picked up more books related to physics, more on the popular science end. And so it wasn't the perfect explanation, but it really got me interested in physics. And at some point, I fell in love with it. And then I went back to study it in university. And so I think that we need to start with exposure at younger ages. Yeah.
Yeah, we have to grow the quantum native student in the elementary school. Okay, it's a time's up, unfortunately. Yeah, in this session, we discussed about how our effort in the journalism and then the communication and social media things. Okay, please, we can continue all this discussion even in the lunchtime in offline participant. Okay, please thanks to all the speaker again.